Hi, DocRevis here with Watch Me Work It. Drawing easy Lewis structures. Let's start with the Revis rules of order for drawing them. Draw the individual dot structures. This allows you to focus on the single dots to get things started. Rule number 2, connect single dots as obvious bonds. This creates the initial connectivities. Basically, this creates sigma single bonds. Combine any leftover single dots. You hope not to have them, but just in case you do, combine them to make new lone pairs. Then number 4, shift lone pairs to satisfy appropriate octet rules. This makes for multiple bonds. So basically, rule number 1, for example, carbon, you would draw 1, 2, 3, 4 individual dots. And we notice we have 4 unpaired electrons. Therefore, we have 4 initial places that we could start to make connections. So if we had 4 hydrogens, for example, we could make these connections at here, here, and here. And this would lead to a Lewis structure. So let's do some Lewis structures. Well, what do you know? We have CH4 to do. So let's do it. Here's carbon. So let's take carbon. And I'm going to consider carbon to have 4 sides for putting the dots on. That way I don't pile them all together. 2, 3, 4. And this system will work out really well when you get to group 15. How do I know carbon has 4 dots around it, by the way? 4A, 4 valence electrons. Oh, this 3A, that would be 3 valence electrons. Okay? So we have carbon with 4 valence electrons. So if we want to put hydrogen, we would have 4 hydrogens. And they would have 1 electron, 1 valence electron. And so I would have 4 of them. And my initial structure, what I would simply do is just kind of, I would want a bond to go there because they're individuals, a bond to go there. I would want a bond to go here and a bond to go here. And then I just straighten them out so they look all nice and neat by turning them into nice, neat, single bonds. And that will be methane, CH4. Let's do carbon tetrabromide. Same concept. Carbon, 1, 2, 3, 4. And this time I have bromine. I would have draw bromine. Bromines in group 7A, therefore 7 valence electrons. So I would draw, watch this, 1, 2, 3, 4, 5, 6, and 7. I highly recommend that you follow this system because this allows you to see the initial connectivity as well as the geometrical angle. Okay, so let's draw 4 of these. I'm going to follow my system. 1, 2, 3, 4, 5, 6, 7. I didn't quite get to 7. There we go, 7 now. Next bromine, put more bromines. 1, 2, 3, 4, 5, 6, and 7. And let's just put one more bromine over here out of the way. 1, 2, 3, 4, 5, 6, and 7. I notice I have 1 opportunity for initial bonding here. 1 for this, 1 for this, 1 for this. So I'm just going to take the obvious, rule number 2, take the obvious bonds. I'm going to connect here. 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 And do the obvious. Bromine, I didn't have to use these electrons, so I'm just going to put them back on there. They're still there. I use the single dot here. That's a bromine. 1, 2, 3, 4, 5, 6. Here we go with another bromine down here. Didn't bother these, so I just put them right back on. There, I drew a bond here. And every 2 dots equals a bond. So there we have it. The tips of these are dots. They're right there. There you go. And then you just connect between them and you have it. And there we have it. So we didn't have any leftover bonds. So we didn't have any leftover dots, excuse me. No single leftover dots. Therefore, nothing to do here. And nothing to do here because if you follow the system for simple Lewis structures, more times than not, it will work out to fulfill the octet. 2, 4, 6, 8. I'm happy. 2, 4, 6, 8. Happy. 8 there. 2, 4, 6, 8. So we're happy to do that. So everything here is working well for us. Okay. On to the next one. Let's follow the rules. Let's do here. Ammonia, NH3. So nitrogen is going to be the central atom. I know that because it has the best opportunity to be the central atom because it has more unpaired dots in it, and you'll see that in just a minute. There are 5 valence electrons. So I start here, 1, 2, 3, 4, 5, and I draw the hydrogens. 1, just going to spread them about here, 2, 3. If I look at my opportunity to bond, hydrogen has an opportunity to bond once, and once. Here, nitrogen has opportunity to bond 1, 2, 3 times because of the single dots. I will ignore the lone pair because they are grouped. They're grouped together, which means they're spin up and spin down. They're very happy sitting there. All these others are spin up, and they're looking for an opportunity to spin down with something else. So I'll bond here, 1. Take that line out. 2, take that out, and 3. And then I'll just group them together and make them look all nice and neat. And there I get ammonia with the lone pair. Didn't have to do anything. I check the octet rule, 2, 4, 6, 8 around nitrogen and 2 around each of the hydrogens. Very happy. Let's do water. Water, central atom, oxygen, 1, 2, 3, 4, 5, 6. That's my best opportunity for bonding is going to be 2 here because I have 1 unpaired here, 1 unpaired here. These are lone pair, 2 sets of lone pair. I won't use these unless I absolutely have to. Check off here. Let's put these hydrogens. I'm going to put 1 here. I'm going to put 1 over here out of the way. And so I've done that. The best opportunity for single bonding right there and right there. Then I'll just simply redraw it and make it look a lot neater. And if you notice something here, the geometry here is bent geometry. If you use this system of going around the atom and considering it to have 4 sides for everything between group 14 through 17, that is 14, 15, 16, 17, actually, and 18, it'll serve you well, okay? And you'll get an idea what the geometry is along the way. So here, that's water, bent geometry here, octets fulfilled, and I didn't even have to check it. I know it's going to be good. All right, let's go to the next one. Here we have boron trichloride. I'm going to rule number 1. Now, in this case, 1, 2, 3. But when I look at that, I recognize this really would look better if I drew a triangle. So I'm just going to go ahead and redraw it. Yeah, now it looks a lot neater and more distributed. There we go. So now we have that. And then I'm just going to put 3 chlorines, 1, 2, 3, 4, 5, 6, 7. I see already have 1 opportunity to bond here. I'm going to put a little chlorine over here. 1, 2, 3, 4, 5, 6, 7. 1 opportunity to bond. I'm just going to drop another one right up here. 1, 2, 3, 4, 5, 6, 7. You notice I don't just do that double dot thing. This lets me know my initial opportunity to bond. And that's what we're after here when we do this rule number 2. Okay, that's what we get when we do rule number 1. Now, rule number 2, we're on to the obvious bonding. So here we go here, then we go here, and we go here. It didn't take me long to figure that out, did it? So now I have boron, and I want to make these atoms be a little bit distributed. I just dropped these dots in because I didn't bother them. Didn't draw this one too well, though, did I? That's okay. And then I have a third one here. By the way, that is a Cl. This equals Cl. So we have the Cl. We have a distributor here. We look around the 8 around each of the chlorines around boron. I'll have 6 I have 6 uh, electrons around boron. And that fits well because this is 3A. In group 3A, its octet is very satisfied at 6. We could draw a resonance structure here, which we'll talk about it perhaps in some other slides, where you could get a double bond that will put a plus charge and a minus charge where you prefer not to have them. You have a minus charge and a plus charge where you prefer not to have those. So that works out really, really well. On to the next one, and that does it.